All right, so you guys ready to go? Let's talk about, before we begin, we're talking about operations with matrices. We got to talk about there are three ways that we can actually represent a matrix. I'm going to write them down for us. There are three ways to represent a matrix. Okay? The first way is with a basic old capital letter, like A, like B, like C, D, blah, blah, blah. Any old capital letter or uppercase letter will represent a matrix. So anything that's uppercase, that's pretty straightforward. The second way that we sometimes see matrices represented are these brackets. These brackets with entries like A, I, J. Or we could talk about matrix Bij, where the I is representative of the rows and the J is representative of the columns. So you might see that as well, like Aij or Bij with brackets around that. That's the second way that we could talk about a matrix. So we have uppercases, we have sort of these entries. I call this the entryway, right? Like, not the entryway, like entries, right? So, and then the third way that we could represent a matrix is kind of like a combination of both of these. You might see something like uppercase letter A is the same thing as entry Aij with brackets, which is just the same thing as our normal way of representing a matrix as a rectangular array of entries. So like A11, A12, blah, 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 all the way down to A1n. And then going down in the columns, AM1, so that then the diagonal just becomes AMN. So what does the MN represent in this case? Yeah, so this is the rows and columns, right? So an M by N represents our rows by columns. So these are the three ways that we have that we could represent a matrix, right? Uppercases or entries, rows and columns, or kind of a combination or a rectangular array of all of these. So you have to know that to sort of just begin. And that's just a basic setup for what we're working on. Easy enough, you guys? Yeah. Okay. So this is the idea of when are two matrices equal. There's a couple of things that have to happen in order for two matrices to be equal to each other. Do you have any clues or any thoughts or any guesses of what they might be? Same. What do you mean by numbers? Order. Yeah, the same order, exactly. So they must have the same order. Whoa, same order, and they must have the same entries. You got it. Same entries. So as an example, right? If I had, if I called A11, A12, A21, A22 equal to this matrix, 5, 6, -7, and 8. Well, what's the order of this? This is a 2 by 2, and this is also a 2 by 2, so that takes care of the same order. And then all entries must be the same, meaning that this position must correspond to that position. So A11 must be 5. This position must correspond to that position, and so on and so forth, all the way around, right?
Would they have to be the same?
They would have to be the same entries, right? Same value, yes. So same order and same value, okay? So it literally is, like this. As an example for you. I know, man. This is not as that. So 2, -1, positive square root of 4 and a half. Is that equal to this matrix? 2, -1, 2, 0.5. It really, literally is. Yep, that's simple, right? This is a 2 by 2. This is a 2 by 2. So they both have the same order, and every single corresponding entry is the same. So therefore, these two matrices are equal. Like if I'm taking the principal square root of 4, and of course a half can be represented as 0.5. Not terribly all that exciting, right?
I think it's so exciting.
Everyone's like, wow, this is amazing. This is the easiest thing we've ever done on here. Okay, so what about this one? How about 2, -1? How about 3, 4, 0, 0? And this matrix here, how about 2, -1, 3, and 4? Are those equal to each other? Yes or no? What do you think?
No.
Okay, no, there's a specific reason. What is the specific reason?
Not the same order.
They are not the same order. What's the order of this one? This is a rows by column. How many rows? There's a 3 by 2, and this is a what?
2 by 2.
There's a 2 by 2. Therefore, their orders don't even match up. So there's no way they can be the same. Even though these entries match this entire matrix here, they're not equivalent because their orders are totally different. Okay? Let me give you an example for you guys to do. Okay? So I'm gonna give you this. I'm gonna give you two matrices here, and I'll give you this: x plus 2 for that entry, 8, -3, 1, 2y, and a 2x, and then finally 7, -2, and a 2y, and this one a 2x plus 6, an 8, a -3, a 1, a 18, a -8, a 7, a -2, and an 11. Okay, so if you have this information, can you figure out what x and y are? So I'm asking you to find this, 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 and this. Yes, sir.
Isn't this matrix not possible because the 2y, the numbers are different?
You got him, Max.
Yep.
I wrote down on my notes. Hold on a second. Okay, so yeah, thank you for catching that, right? This should not have been a 2y, should have been a y plus 2.
Can't you just find x and y's and z's with this information?
Yeah, you sure can.
You only have x and y though.
So that means you're going to associate that one with that one, right? This one with this one, right? And then hopefully these need to match up if they are equivalent, right?
Yeah.
Okay. So what's the easiest one to find? So x has to be what? X has to be -4. Yep. X has to be a -4. Does that work in this one? -4 and 2. How much is -4 and 2? Was that -2, right? And then a -8 and 6. Yep, that's a -2. Awesome. And then how about y? Y has got to be what? 9. There you go. So does that work here? It sure does. And it must also work here once we actually corrected that error, right? And 9 and 2 is 11. Yep, that actually works. Fair enough. So this is all matrix addition. And it literally is what you would think it would be, right? So I have two matrices here. We're going to do two examples, A and B, and talk about matrix addition. And we're going to spend the next minute talking about this. What's the order of my first matrix here?
2 by 2.
That's a 2 by 2. How about the second one there?
2 by 2.
A 2 by 2. Good. And how about this one down here in B, example B?
2 by 3.
That's a 2 by 3. What about this one over here?
2 by 3.
A 2 by 3. All right. It's important that if you're adding two matrices together, they must have the same order. Okay? So therefore, my grand sum total here, what do you think it's going to be? What's a 2 by 2 plus a 2 by 2 going to equal?
2 by 2.
Actually, it's just going to be another 2 by 2. Some people say 4 by 4, right?
Yeah.
Right. Okay, what about this one over here? A 2 by 3 and a 2 by 3. What's that going to be?
2 by 3.
Another 2 by 3. Yes, this is going to be a 2 by 2, and this one will be a 2 by 3. So if you had to take a guess, and you only had one guess as to how you would add these two matrices, look at all the hands shooting up in the air. Paige, what do you think? What would you do? What do you call those? I know exactly what you're talking about. There's a word for them. Yeah, corresponding entries, right? So the one over here and the one over there add to a grand total of 0. Very good. The 2 over here and the 2 over here add to a grand total of good. 0, -1, and then you pick this up real fast, right? Like I said, super easy. Don't be sorry. I saw that. Okay, so let's do this one really, really quickly. 2, 0, -2, 9, 5, 14. Okay, good. You guys get it. We are going to take this matrix, which is a 2 by 3, and we're going to multiply it by a scalar. The 3 on the outside represents our scalar. So if we want 3 times this matrix, if you had one guess, and one guess only as to what you think you do, what do you think you do for this, right? Yeah, Megan, what? You multiply, yes, she's right, each entry. So I'd have 6, 15, 3, 18, 0, -3. So do you remember me asking you if you could multiply at the beginning of the lesson? No, you don't?
What did you ask?
I asked I asked everybody. Okay. Okay, here's a challenge problem for you. Okay? Okay, let's let matrix A be this matrix here. I think I want to do... Yeah, okay, we'll just do this one. Okay? How about this one? We'll do 2, 2, -3, and 0. and let matrix B be this matrix over here. 1, 0, 3, and 4. What would then 3A plus 2B, what would that end up being? Go ahead and work on that real quick. Did everyone get 8, 6, negative 3, and 8?
Yes, sir.
You guys are awesome. So let me explain the U-try, right? I'm giving you two matrices. I'm giving you A is equal to a 2 by 2, and B is equal to a 2 by 2. I would like you to find a matrix X that would look like this, a 2 by 2, such that 3 times that matrix you find plus this matrix A, which is defined, would give you matrix B, which is also defined. So what would be a clever thing to do before you even start? Steven, what do you think, buddy?
Isolate X.
Isolate X over here, and then solve your matrix. Okay, so see what you can come up with it in your table group. All right, so to isolate this, you guys get your matrix X has to be matrix A minus matrix B, and then multiply by the scalar of a third. Did you guys do it that way?
I got negative A plus.
Yikes. Thank you. B minus A multiplied by a third, right?
Yeah.
So when you're all said and done, you should have got negative 4/3, 2, 2/3, and a negative 2/3. Everybody get it?
Yes.
Awesome. Okay, sweet. So I've got two matrices here, right? This is the more challenging part. So we can add and subtract matrices just like you think you would. We can use a scalar matrices just by multiplying every entry by that scalar, okay? Not very challenging. Let's close that lid. There you go. Thanks a lot, buddy. All right, so here's question number 1. What is the order for matrix A? Tell me the order.
3 by 5.
This is a 3
By
3 rows by 2 columns. What is the order for matrix B?
2 by
This is a 2 by 2. Okay, here's the first question I have for you that I want you to think about, all right? Are we even allowed to multiply matrix A times matrix B? What do you think? Take a guess. Yes or no?
No, say no.
Okay, who says yes? Hands up. Let the record show that 5 or 6 people are saying yes, we can. Who says no, we can't multiply matrix A times matrix B? Let the record show that 4 people say no. Okay? So some say yes, some say no. Here's the next question I have for you. Can we multiply matrix B by matrix A?
Yes.
Who says yes for that one? Hands up. I say 1, 2, 3, 4. Let the record show 5 people say that. And then who says no, we can't multiply B by A? Nobody says that, so it looks like I'm confusing everybody. All right. Now, here's the third and final question. Are they the same?
What?
You mean
No.
Is A times B the same as B times A?
no?
Well, what's 4 times 8?
Potentially. Please don't.
No, matrices are different.
32.
32. What's 8 times 4?
Matrices are going to be different.
32 does not equal 32.
So what? Hold on. What do you call that property that I just demonstrated for you? There's a name for it. Commutative property, right? So is it the same for this one?
No.
We're going to do a little exploration, bust out your calculators. Here we go. So excited.
Oh, if you watch it, it's like a matrix multiplication problem or something.
Nah, I don't. Who said they don't want to? You love this stuff, man. This is awesome. All right, here we go. Wait for it. Here we go. Turn your calculators on. Go to matrix. We're going to go to edit, and I want you to enter in A and B. Matrix A was a 3 by 2. Awesome. 3, enter, 2, enter. Okay. And so enter this in. Negative 1, bam. 3, bam. 4, bam. Negative 2, bam. 5, bam. 0, bam. Okay. Second quit. Say, hold on. Shh, don't do anything yet. Okay. Then they go to edit and go down to matrix B. Plug this in. This is a 2 by 2, right?
Yep.
And then is a negative 3. Enter, 2, enter. I don't want you to multiply them. I just want you to plug this in. I have more questions for you afterwards, okay? I don't want. All right, and then second quit. So you should just have these two matrices entered in. And that's all I want you to do right now, okay? Fair enough?
Yep.
Okay, so now looking at this, okay? Let's assume that one of the two operations can happen. Either we can do A times B or B times A. Let's just assume that one of those is true because it's probably the case that one of them can work, at least one. My question to you, and if I have a 3 by 2 order matrix A and a 2 by 2 order matrix B, then when I multiply them, what would you expect to get?
2 by 2.
A bigger.
2 by 2.
3 by 2.
A 2 by 2?
2 by 2.
A 3 by 2?
2 by 2.
A 6 by 4?
6 by 4, yes.
Probably,
Yeah.
I'm just guessing 3
Uh,
by 2.
I know.
A 6 by 4 and then multiply that 24? I mean, what, right? No, I don't know. So what is it? So here's what we're gonna do, okay? Let's do a little investigation.
It's 3.2.
We're gonna go
I'm going with 2 by 2.
2 by 2? Okay.
I'm going by 3 by 2.
A 3 by 2?
3 by 2.
Okay.
2 by 2.
Ooh, so exciting.
No.
3 by
Okay.
2.
Second matrix, we're gonna go 1
2 by 2.
times.
3 by 2.
I love it, man. It's so awesome. You guys are so inquisitive. Okay, so A times B, push enter.
3 by 2.
Oh, it's a 3 by 2.
Got it wrong.
3 by 2. Okay. All right. Now let's do the other way around. Let's do second matrix B
It's a 2 by 2.
I just did.
times second matrix A, and I get error.
That's not good.
Dim. What's dim? You know what that means? It means dimensional mismatch. You have a dimensional mismatch. Okay.
I get it.
All right. So we've learned a few things now.
So you can only multiply like a bigger one by this one.
All right. So it turns out matrix multiplication is not commutative, like it was back in third grade whenever we learned it, right? So there's something else going on here. So let's talk about this, right? Here's what you have to do first. If you're going to multiply two matrices, you have to make sure. Whoa, sorry about that. You have to make sure that the two inside numbers must match. Okay? So this and this, now let's think of what does that represent? That represents the column, right? Rows by column. The column of the first matrix must match the rows of the second matrix. Okay? And the cool part is this. The leftovers, the 3 on the 2 on the outside, this will be the result. The result. The result / the order of your product.
No, what do you mean 3 by 2?
Okay? So if I multiply a 3 by 2 by a 2 by 2, the inside numbers match, meaning I'm allowed to do it, so I have permission, right? And then the result or the order of the product that when I multiply it will be a 3 by 2. Okay?
Oh, I get it. So
Okay.
like, if you, let's say that it was a 2 by 3 and it was like
Yeah.
2 by 2.
Let's say I have this. Can I multiply a 2 by 3 and a 3 by 5? Can I do that?
Yeah.
Yes, because
Yeah,
those
so
match,
row and column.
and I'll have a 2 by 5 as an example, as a result.
This is all just in the
But
calculator. You can't,
how
like, do
about
this
if it's
by
like, how about
Hold on.
if it's like 2 by 3
Okay, a 2 by 3, yeah?
and then it's like a 2 by 2?
And then a 2 by 2.
So that
Can you
means
do that?
No.
then you have to switch that.
So I cannot do it this way because those don't match, right? But I could do this, a 2 by 2 and a
2 by 3.
2 by 3. That I can do because those match and my result would be a 2 by 3. So there's a way to do it, right? Now, the reason that the two insides have to match, the column of the first one, the rows of the second one, is because that's how we actually do it, okay? So, ladies and gentlemen, we're going to actually figure out, my next question for you is, okay, how the heck did they get a -9 here?
Oh, 3 by
That's
negative,
magic.
3 times negative 3.
3 times -3, that's a -9, true. But was that same thing hold true for, say, this 10 down here? If you take that same logic?
Oh.
Huh.
Times 2.
I don't like the mixed
I don't like that.
Okay, all right. So our goal now that we know what we can multiply, we need to know the how do we multiply. Okay? So
Day 2.
no, this is where day 2 would happen, but since we are the advanced class, we're gonna push on through and get it. Okay? So here we go.
A plus.
Okay, so here we go. I'm gonna rewrite.
Giving yourself more.
It's half an hour.
Okay, I'm gonna give you -1. Okay, so we're gonna do this, and I'm gonna show you how to do this. Okay?
2 by 2, the last one.
Oh, sorry, 2 by 2, thanks, yeah. 2 by 2. I'm going to show you how to do this. So if I am multiplying a 3 by 2 and a 2 by 2, the result will be a 3 by 2, correct? So the way that I do it, the way I teach my students how to do this, is I make a huge 3 by 2. And I mean huge 3 by 2. Okay? And then I make a small 3 by 2. Okay? I make a huge 3 by 2 and a small 3 by 2. And the reason is because I'm going to have 1, 2, 3, 4, 5, 6. I'm going to have those 6 entries. Is that correct? Let's go with that. I'm gonna have those 6 entries, right? Then over here, I draw bigger ones. Entry there, entry, entry, and you'll see why in a minute. Okay? No, these are both the same. These represent the same thing. I'm gonna show you how to get the answer. Okay? We know what the answer is, right? The answer is right there. We're trying to get this. -9, 1, -4, 6, -15, 10. That's what we're trying to get. I'll show you how to do it. Okay, so ask yourself, what position is this? This is row 1, column 1. This is row 1, column 2. This is row 2, column 1. This is row 2, column. This is row 3, column 1. This is row 3, column 2. Good. So all of these correspond to the same over there on the little one, the baby one, right? So this is the pot, like the big one, and then the baby one, right? Yeah. So check this out. We're gonna multiply row 1 and column 1 and add their results. So here's how you do this, okay? So I'm gonna take, here's row 1 and here's column 1. You guys agree with that? Here's row 1, here's row 2, here's row 3. Here's column 1, here's column 2. Agreed? Check this out. I'm going to take the first entry in row 1, which is -1. I'm going to multiply it by the entry in matrix B, -3. So I have a -1 and a -3, plus a 3, which is this one here, times a -4.
Why? -4.
Huh? Because that row 1 times column 1. So how much is -1 and -3? That's 3. And then how much is 3 times -12? 3 times -4.
-12.
So what's -12 plus a 3?
-9.
And that's what goes over here. That's how it makes it to the answer over there. It's not hard. It's just funky, right? You just got to keep track of what you're doing, okay? So let's go to row 2, column 2. Okay? I'm going to multiply row 2. Oh, sorry, row 2, column 1. Let's do this one. Row 2, column 1, right? So I'm going to have this. I'm going to have a 4 times -3 plus a -2 times a -4. So that gives me a -12 plus 8. How much is that? Which is a -4. How are we doing so far? Are we getting this right? Check this out. Ooh, the -9, -9, -4, -4. Things are looking good for us, okay? Okay, then I'm going to do row number 3 with column number 1. So it's going to be 5 times a -3 plus 0 times who cares, right? So what's 5 times -3? -15. You guys catching on to this? It's kind of funky, right? You love it. Okay, let's go to row 1, column 2. Row 1, column number 2. I'll use green, right? So this is going to be -1 times a 2 plus a 3 times a 1. How much is that?
1.
3. That's how much? 3 minus 2 is that 1? Are we still on track? Check it out. Oh, there's a 1 there. Awesome. Okay, here we go. Row 2, column 2. Row 2, column 2. So I'm going to have, what is that going to be? 4 times 2 plus a -2 times a 1. Was that 8 minus 2? Is that 6? Awesome. Last one. Here we go. This one times this one. So 5 times 2 is 10 plus, who cares? 10. Right?
Yes.
And there is our answer. And that is how we got this right here. -9, 1, -4, 15, blah, 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 blah.